Okay, so what we're going to do is today is the 21st day, and what we have is we have three different things that we're doing today. And so what I'm going to do is I'm going to probably be breaking these up into three different sections. They'll be short videos, but I want to kind of make them small so that if you're looking for one or the other, you can just look at the video instead of watching the whole thing. So let's look and see what we're doing today. So first of all, what we're going to be doing is we're doing page 325 to 340. We're not going to 340 at all today. We're not even getting that far. But first what we're going to do is mass and the mole. Okay? We talked about what a mole was yesterday. And so now what we're going to do is we're going to talk about a molar mass. Now, from now on, you will need to have your periodic table with you because remember, molar mass is the AMU. And remember, the AMU is right there on the left-hand side. What that is it tells you how many grams there is to make 1 mole of hydrogen. Now remember, 1 mole of hydrogen will have 6.02 times 10 to the 23rd molecules in it. All right? So I want to make sure you get that straight. Molecules, 6.022 or 6.02 times 10 to 23rd power is the number of molecules. But then when we're talking about a mole of a substance, like the mole of beryllium, we're going to talk about the AMU, which is 9.01. And you're going to need to know that to be able to do it. So in the textbook, it talks about jelly beans. And it talks about, they're giving you an example of 1 jelly bean actually weighs 35 grams. And what it's trying to do is it's trying to see if you can figure out how many grams 5 dozen jelly beans would be. Okay? So, if there are 35 grams per dozen, and that's what it's saying here, there is 179 grams of jelly beans. Now, you're going to have your calculator today. Okay? So, if we go, first of all, we're going to do is we're going to go ahead and turn it on. We're going to look and see what we've got here. So we're going to look at our settings. Right now I'm in normal, which will be fine, and we can toggle back and forth, and I'm also in radian. So to be able to do this, remember, the dozen jelly beans is just a unit of measurement, okay? So we're going to do 5, open bracket. Here is a fraction. Remember, fraction, alpha, y, enter. And you want to see this 2 lines here. 35. And you're going to go over, and you're going to go 1, you're going to go over again, and you're going to close your bracket, and you're going to hit enter. And as you can see, I have 175 grams of jelly beans. So the first thing we're going to do is moles to mass. Okay? So we're doing moles to mass. So to be able to do moles to mass, we're going to have the number of moles times the mass of grams over 1 mole. All right? So we're going to have number of moles, grams over moles here to actually find the mass of the grams. That's what we're looking for. So it gave us a scenario in the book, and it said that there was 0.4050 moles of CR. The molar mass was 52 grams, and it was going to asking us what the grams would be if we had this much. So if in our calculator we would do 0.0450, open bracket, right guys? Alpha y, enter. 52.00, down, 1, over, close your bracket and hit enter. And I got 2.34 grams of CR. Okay? So it's moles times grams over moles. So let's look and see what we have here. We have these problems here. So what they're doing here is they're telling us in our textbook that we have 3.57 grams of aluminum. And they want to know how many grams would that be. Okay? So that's just basically telling you there's 3.5 of aluminum. Okay? I have 3.5 of aluminum. So what I'm going to do is I look at aluminum. 2698 is the AMU, right? So I'm going to do 3.57, open bracket, alpha Y, enter. I'm going to do 26.98. Where did I get that from? I got it from my periodic table, and I had to find it from my AMU, over 1 mole, over, close bracket, and I got 96.3. Look at the 1 there. That's the reason why I rounded it to the 3. Okay? The next one said I had 42.6 moles of SI. So, SI on the periodic table, where is SI at? So, SI is right here, is 2809. Do you see it? So, I'm going to do 42.6, open bracket, alpha Y, enter, again. I'm going to be 28.09, it's because what I said, over 1, close, and then I'm going to close my bracket, and I get 1196.634. Now, if you put that down, that's perfectly fine with me. Or you can change your mode to scientific, because I did, because I wanted to get another different way of doing it. And you're going to do second, answer, enter, and I get 1.19 with E3. Do you see that? Since that's a 9 after that, I changed it to a 2. And then I converted it to the power of 10. Okay? The next one says it's talking about copper, or CO, cobalt. Cobalt is right here, 58.93. Do you see it? So we're going to take our 3.45. We're going to open our bracket, alpha Y in our enter. We're going to do 58.93 over 1, over, close bracket, enter. And I get 2.03 times 10 to the 4th. The next one talks about ZN. So we have to look on our periodic table. There is zinc there, 63.38. That's where I got that number from. But this time is an expanded form. So it is 2.45 times 10 caret negative 2 over, open bracket, alpha Y, enter, 65.38 down 1, over, close my bracket, and press enter, and I get 1.6 E0, which I keep it at 1.6 grams. So, in this lesson, we talked about moles to mass. We talked about molar mass. So, I'm going to post this one as moles to mass, and that's just the first section.